So, inclined planes are situations where we kind of have a ramp, right? And we have an object on the ramp, and it's either moving or staying still, and we need to figure out some of the values associated with that object. So how fast it's going, what force is acting on it, that kind of thing. Sometimes inclined plane questions can get a little bit more complex. Sometimes they involve multiple different objects, multiple ramps, multiple pulleys, that kind of thing, but we'll just focus on the more simple ones for today. The most important formula you need to know is F equals mg, which hopefully you've heard before. So F is the force of gravity, m is the mass of the body, and g is the gravitational field, or the acceleration due to gravity of Earth, which is negative 9.8. So, one of the most important values that you need to understand for inclined planes is normal force. So normal force is the force perpendicular to the surface of the object. Alright, so if you have a look at the diagram on the right, the F norm is the force perpendicular to that surface. So the diagram depicts a free body diagram of a 1,000 kilogram roller coaster on the first drop of a ride. Calculate the net force and acceleration of the roller coaster, and then assume a negligible effect of air resistance and friction. So, we know that here our mass is 1,000 kilograms. Our force is going to be F equals ma. So you could calculate the answer to that using that formula. Let's get on to an example question, and this one is from a previous external, as you can see. So here we have an inclined plane with a an object on it. We have a force due to gravity acting downwards of 45 newtons and an acceleration of 12.5 newtons up the ramp. We also have an incline of 30 degrees. The question asks us to calculate the time it will take for the object to slide 10 meters along the slope. So, let's start by writing out the information that we know. So we know we want to calculate the time at when the object has slid 10 meters. So when the displacement is 10. We know that the incline of the plane is 30 degrees. The force due to gravity, which is, remember, force due to gravity is mg, is also equal to 45. So as you can probably see from this, we can actually calculate the mass of the object, because we know that g is 9.8. So 45 divided by 9.8 will give us a mass of 4.59 kilograms. Now we know the force of acceleration up the plane is equal to 12.5. Alright, so now what we need to do is we need to have a look at some of our linear motion formulas to see which of those can apply to this scenario. So I'll take you guys to the second page of your formula sheet, and I'll show you guys what I'm looking at here, and I'll show you the process of how you can actually determine what formula you're going to use, because once again, it's kind of difficult for some students to figure out which ones they need to be using. So, here are the formulas that you'll be able to see on your formula sheet. Alright, as you can see, we're trying to find the displacement, or rather we have the displacement, and we're trying to find t at that value. So it seems most likely that we're going to be using this equation here. Alternatively, we also have this equation down here, which also has the displacement in it. But have a think about which one we would use and why. Alright? So, for either of our equations, we could potentially use either of our equations. The only thing is, in this second one here, we have v squared. Remember, v is the final velocity. So, we don't actually know the final velocity here. We also don't know the length of the slope. So we likely are not going to use that either, because we don't know for sure that if the object slides 10 meters down the slope, it will come to a stop. All right. What we do know, however, is that the initial velocity is is 0, because it's initially at rest. So it seems like we would be using our first formula here. So we're going to have S equals, and remember S is 10 here. 10 equals ut, so u is 0, t, plus half. Acceleration is 12.5. T squared. Now, if you're a particularly astute student, have a look at the working here and figure out what is wrong here in this line of working. What have we done wrong? Take a second, pause the recording and see the mistake. Alright? So, what actually is wrong is that our acceleration, A, is actually not 12.5. The force of acceleration is 12.5, but our acceleration itself is not 12.5. So what we need to do instead is we need to figure out a way to find the value of the acceleration. So, the force parallel to the plane, alright, we actually have a formula for that. So the force parallel is actually equal to Fg sine theta. Alright, so Fg here is 45, and then theta is 30. So we can find the force parallel along the plane. So we'll get 45 sine 30 gives us an answer of 22.5 newtons. Alright, so this is the force parallel to the incline of the plane. Now that we can find that, we can actually find the net force. Alright, the net force which is acting on the whole system, because of course we have the force of acceleration up the plane, maybe somebody is pulling it up or something like that. We have the force acting down the plane from gravity. We can find the net force parallel to that plane. So, the net force will just be, if we think about it like this, the force parallel down here will just be running like this. This will be 22.5. So the net force will be 22.5 minus 12.5, which gives us an answer of 10 newtons. So, now that we know that the net force is 10 newtons, we can actually figure out the acceleration, because the acceleration is a product of, not necessarily a product, is a result of the net force. Alright, you can't find the acceleration just from a single force in the diagram, you need to have the net force. Right, because now that we know that 10 newtons is like the net force acting on the box, that is proportional to how much it will accelerate. So our net force 10 is going to be equal to ma. F equals ma, right? M is 4.59 a, and we can solve this to give us our value for acceleration. We're going to have 10 divided by 4.59, which is going to be equal to 2.18. Now we actually have our value for acceleration. We can pop that back into our equation. 2.18. And now we can solve for t. So we're going to have 10 divided by 0.5 times 2.18, and then we're going to find the square root of that. Alright, and this will give us an answer of 3.03 seconds, or nearest to the whole number, 3 seconds. Alright, so that was a pretty simple overview of inclined planes. Nothing too crazy happens in inclined planes. All you mostly need to know is how to apply those formulas that you've been given, and then how to find the parallel forces. Alright, so the force down the plane, or the force parallel to the plane, will be equal to Fg sine theta. And that one isn't on your formula sheet, so make sure you remember it. Also make sure you remember that the acceleration, the total acceleration, can only be derived from the net force. So if you need to find the acceleration of an object, you need to find the net force first. Alright,